Alright, so today we will be looking at multiplying polynomials part 3, and basically we will be looking at some problem solving. So if you go to your handout on example 3, example 3a, you will find this. And just like before, I'll do one and you guys do the rest and we'll take it up. Okay, so this question, right? It says to write and simplify an expression to represent the area of the shaded region. So what we have here is something that is not, well, it's a composite figure, right? Composite figure made up of many different geometrical shapes. So essentially we have two rectangles here, right? Two rectangles and they're asking us to find the area of the shaded region. Now, so it's a composite figure made up of two rectangles. So let's divide this into rectangles. Let's see if we can figure out what the rectangles are. Okay, you can, I would say it's pretty obvious like this. So you can extend this, right? And then we can simply simplify, we can add this area plus that area and that will give us the total region, right? However, we still need to find certain side lengths. For example, we know that this side length is 3x plus 1, right? We know that this one is 2x plus 2. We know this one is 2x and this is 2x. So, for example, if we needed to find the area of this region, right? Let's call it area 1, right? Area subscript 1. And let's call this one area subscript 2, right? If we add the two areas, we will get the total area, right? So in fact, I'm going to add it here. I'm going to call it A underscore subscript T equals to area 1 plus area 2. Now remember, they want us to find out an expression for this, for the shaded region, right? So we are working towards that. Now, if we needed to find the area of this rectangle of area 1, right, we need to multiply the length times the width, right? We have one dimension here. Let's call that the width, 2x. What is the length of this? Right? How can we figure that out? Well, if we know that this is 3x, this one at the bottom is 3x, and this one is 2x, if we subtract this from that, we will get the length of this, right? So we can extend this. Right, I'm going to extend this here too, right? And if we find the length of this, right? Yeah. Okay, we find the length of this. So this is basically what is given to us, right? Let's put given here, just so that we follow the format that I have been promoting from the very beginning. So this is given to us. Alright, so we need to find this area. So how do we find that area? Well, we simply, as we said, we can subtract these two side lengths to 3x plus 1 minus 2x, and that will give us this length, right? So we do that. 3x plus 1, right, minus 2x. Now I will put this in brackets, but since there's a positive in there, not a big deal. Alright, so what is this equal to? Well, this length here is going to give us 3x minus 2x gives us x plus 1, right? And that's it. So that's the length of this. From here to here is x plus 1. So now we can find the area of this region. And the area of this one, the second region, would be 2x times this, right? Length times width, right? Same here, length times width. Okay. Once we have that data, right, we know that this is what we are required to find. So RTF, I suggest you follow this format always, right? Now that we have our data, let's start developing our solution, right? So let's put here solution. Okay, and just so that we can see what the length is from here to here, I am simply going to expand this and just say that x plus 1 is this from here to there, right? It ended up at the top. I just wanted to make sure that it appears. Okay, so let's start substituting our values here, right? So we have total area is going to be area 1. Area 1 will be 2x times x plus 1, right? Area 1 would be 2x times x plus 1. 2x times, so length times width, right? Length times width. So let's do this. Let's do our 2x times x plus 1 plus area 2. Area 2, it's length times width. So 2x times 2x plus 2, right? So 2x times 2x plus 2. Alright, so we have this expression. So we have the expression. Now we have to simplify this expression. So let's do it. Let's do it. So we can start doing this. So here we end up with, we do the distributive law, 2x times this expression times each of these terms. So 2x times x gives us 2x squared, 2x times 1, 2x, right? Positive times positive, positive. So not much to worry there. Plus 2x times 2x, 4x squared, plus, well, positive times positive, positive 2x times 2, 4x. Alright, let's collect the like terms. Let's collect the like terms here. So, any like terms to 2x squared? Yes, 4x squared. Right? So, in fact, I'll collect them here. We know that that's going to be 6x squared, so fine. Just for explanation's sake. Right, we're collecting 2x as well. And this gives us 2x squared plus 4x squared, 6x squared plus 6x. Alright? This is our solution. This is our expression, right? This expression, 6x squared plus 6x, represents the total area, right? Because we added a1 and a2. Okay, so now we can simply say conclusion, right? Therefore, the area of the shaded region is, right, the area of the shaded region is, right, and you can say area total. Let's put total here, or you can put shaded, whatever. 6x squared plus, it's equal to 6x squared plus 6x. Alright, so take a look at this problem, right? And right, on the second example you have this on the second example. So let's move this here. Right, let's take a look at the second example. Very similar, right? Find the shaded region. You have, right, a big rectangle and a small rectangle in the middle. Is this very similar idea, right? Think about how would you solve this, right? We only need to find the shaded region, not this. Right? Okay, so we'll take this up next time when we meet. Give it a try, but same idea, right?